Hello scholars, welcome. Mr. Hinkle here. Let's talk about glaciers, ice that is on the surface of our Earth, the cryosphere, wildly important component of our Earth system. Let's introduce these amazing features called glaciers. Identify how they form and how they move. So let's just start. Big shout out. The biggest chunk of ice in the world is the Antarctic ice sheet covering the continent of Antarctica. It's massive, it's huge, it's awesome. And it's composed of some individual glaciers, the largest being the Lambert Glacier, 250 miles long, 1.5 miles thick. This glacier is a river of ice. It's kind of like rivers that flow over the surface of the Earth from high elevation to low elevation, but glaciers are frozen rivers. We'll talk about it here. They are vast rivers of ice found on mountaintops, in highlands, natural wonders of the world, and they build up from an accumulation of snow that does not melt annually. In fact, they form over decades, centuries, millennia, and even hundreds of thousands of years. Our current ice core data going back 800,000 years to help us recreate the paleoclimate of Earth's ancient temperature and atmospheric carbon dioxide conditions. So glaciers are important. They cover about 10% of Earth's surface, and they form like so. The snow falls in an area, and it does not melt. The next year, more snow falls, and it does not melt. The following year, more snow falls. Each year, successive layers of snow will add weight that will accumulate on top, compressing the layers underneath and building the thickness as it goes. There is snowfall, which is frozen water, precipitation from the sky, that then turns into firn, dense granular masses of ice crystals that transforms underneath the pressure of the overlying layers into ice. Now, this is important because when the snow is falling, there's pore space in the snow. Loose snow about 90%, granular snow about 50%, firn 25%. Well, the air that is trapped is reflective of the concentrations of what the atmosphere is made up of at that point. And in particular, the amount of carbon dioxide in the atmosphere at the time the snow falls will get trapped in that ice. And this is how we can look to ice to understand Earth history and how Earth's climate has changed through time. Thank you, ice. That's amazing. Glaciers move. They are extremely, this photo isn't moving, but if you watch any time-lapse Chasing Ice documentary, they're extremely dynamic features of the landscape. Internal deformation, where they deform and flow like slow-moving plastic material underneath the pressure, and then basal sliding, where they slide along the bottom of the glacier, and this causes it to carve out the landscape, picking up sediment, transporting it like a conveyor belt. Ice is a very powerful agent of erosion. So we've got the brittle layer and the plastic layer. And it's funny because this is very reflective of Earth's physical layers. Think about the surface of the Earth. You have the chemical layers are crust, mantle, core. And then the physical layers are the lithosphere and the asthenosphere. The lithosphere is made of large coherent blocks of rock that break, kind of like peanut brittle, on the asthenosphere, which is plastic and can flow, kind of like honey. Glaciers do the same thing. In the upper part of it, it's brittle, and this is where crevices form, big breaks in the rock. These are dangerous hazards if you want to go hiking to across glacial landscapes, if you're ever mountaineering, summiting Mount Everest. These are a big hazard you got to look out for. And then plastic, this is where the ice can flow over the surface of the earth. Okay, not only do glaciers move underneath applied force, but they are growing or shrinking. And we call this glacial advance and glacial retreat. So let me build a whole new drawing here for you. I'll put on some mountain, down to the valley, ice cap, and glacier. Snow is going to fall and accumulate. Now, glaciers are rivers of ice that are flowing across the landscape. And where they are building up, this is called the zone of accumulation. And the part down that might be disappearing is called the zone of ablation. Say when a glacier meets the sea and ice calving causes large chunks to break off, or it's melting down at lower elevation. There's an equilibrium line here in the middle where you transfer from the zone of accumulation to the zone of ablation, and then the leading edge of the glacier is called the toe. So here are the components we've just defined. Now let's talk about, are glaciers advancing or retreating? Well, the direction of movement for the ice is always going to be downhill. You would not see a glacier spontaneously moving uphill against the force of gravity. Glaciers move downhill. Now, what does change is the location of the toe. And the proportion of accumulation versus ablation is going to decide or determine, there's the word, determine, whether it is advance or retreat. So for a glacier to advance, accumulation must be greater than ablation. Accumulation greater than ablation. For a glacier to retreat, it's the opposite. Accumulation is less than ablation. So we hear stories, the glaciers are retreating. What does that even mean? Well, it's a geologic process that when we look at the components of glacial movement, ablation is greater than accumulation in the overall glacier, and therefore the toe is receding backwards. Even though the toe is going uphill, simultaneously it's still moving downhill. It's just ablation is occurring at a greater rate than accumulation. So, okay, I guess I should have been on this slide while I described all of that, but this is exactly what I just said. Position of the toe represents the balance between addition of accumulation and loss by ablation, giving us a positive or negative balance, advance or retreat. So glaciers are awesome, wonders of the world, vast rivers of ice that cover about 10% of the landscape. They are very dynamic features responsible for landforms, erosional landforms, depositional landforms, and glaciers come in many different types, these being the subject of the following 3 lectures that I have available for you. Thank you so much. I'll see you again.